So this is Mr. K going through your formative electrolysis lab. So question number 1, the diagram shows the apparatus used to electrolyze dilute sulfuric acid. Complete the box to show the role of platinum. Well, platinum is an electrode, and it is in fact an inert electrode, meaning it does not react, which is important. Otherwise, you could get something like electroplating happening. The next question, give one observation made during this electrolysis. Well, if you look at the diagram, you can see that oxygen and hydrogen are formed. So therefore, we've got two gases. And if a gas is formed, we're going to form bubbles. You could have also put fizz, or you could have put effervescence. Effervescence. Ah. Part C, compare the volumes of oxygen and hydrogen. So in the diagram, I just highlighted them. Actually, let's make the hydrogen, this can be blue. You can compare the two, and we can see that there is more hydrogen gas given off. Oops. More hydrogen, H2 gas, and that would be worth 1 mark. But then for the second mark, because a good exam technique is to check how many marks it is worth, you should be saying that there is twice as much hydrogen as oxygen. The next question, which substance breaks down to form these gases? Now, to answer this question, I'm going to go in a little bit more detail about what is happening. So we have some dilute sulfuric acid. So the ions present in the solution are the following. We have sulfuric acid, so we have H2SO4. So therefore I have a H plus, a H plus, and an SO4 2 minus. It is also a solution, it's dilute. So that means I've got a H2O. So I also have another H plus and an OH minus. So these are all of the ions which are present. 3 H pluses, 1 sulfate, and 1 hydroxide. SO4 2 minus being the sulfate, and OH minus being the hydroxide. Now, with all of these present, you need to think which ion is going to go to which electrode. Now, we only have positive hydrogen as our cation. There is no other cation. There is not another positive ion. So, hydrogen is formed from H plus ion, and this is at the cathode. Okay, and now I'm just going to move this down a little bit. The next thing we want to consider is the negative ion, so that the an ion. Now, the anions present, we have SO4 2 minus or OH 2 minus. These are my anions, and the cation was H plus. So with these two anions present, which one is going to go to the anode? Now, sulfate does not decompose. So the only one which can go to the anode is the OH. I'll say that again, sulfate does not decompose, so it doesn't break down. It stays sulfate in the solution. So OH minus goes to anode to form oxygen. Okay, so whenever you get stuck, always think what ions are present in the solution. If there's water, because it's a solution, you're going to have H plus and OH minus. You only in a molten substance will you not have water there. So which substance breaks down? Well, if we have a look, the two which are going to each electrode are H plus and OH minus, and this was water. So the substance breaking down is water. The sulfate and the other hydroxide ions are staying in solution. So these stay in the solution. So they're not breaking down. Finally, give one test to distinguish between oxygen and hydrogen. So a lit splint test. Now a lit splint, if you put it in oxygen, it's not really going to do anything. It might glow a little bit brighter, which would be acceptable, but generally it will do nothing. Whereas the positive result for hydrogen is a squeaky pop sound. Now the other test that you could have done is the glowing splint. And a glowing splint for O2 is going to relight, and for hydrogen, nothing will happen. A glowing splint isn't going to make a pop sound because there's no flame there. Okay, question 2. A student carried out the investigation to coat a copper key with nickel, and he followed these instructions. So, name this process. Well, this is electroplating, and you could have put electrolysis as well. This would also be acceptable. Why was the key rubbed with sandpaper? So why was it rubbed with sandpaper? And this is to remove impurities or remove dirt. Remove impurities or dirt. And then the second mark, mark 2, is to say for an even coat of nickel. So by using sandpaper, we make the surface of the key very smooth, and this allows for a nice smooth layer of nickel. Smooth surface. Name a possible electrolyte that could be used. So very similar, like I did with sulfuric acid, we want to think about what I need in the solution. Now, if I want to plate nickel onto this, then I need a nickel ion in the solution. So in this solution, I'm going to want a nickel 2+ ion. Now, that means there's also another anion present, and a good one to always use is nitrate. So NO3-. The reason why I say use nitrate is because all nitrates are soluble. So for any question like this, you will want to say the metal nitrate. And we want it dissolved as well, so we'll also want to say aqueous. Aqueous, meaning dissolved in water. Now, if you wanted to plate with, say, copper, or say you wanted to plate with silver, then instead of nickel, the metal here, you would write silver. If you wanted to plate with copper, then you'd write copper, so copper nitrate. If you wanted to write plate with silver, you'd say silver nitrate. If you wanted to plate with nickel, you would say nickel nitrate. So replace the word metal, replace with the metal ion you want to coat with. Coat means layer, by the way. So layer, putting a layer of metal. So in this instance, we are going to use nickel nitrate, and we need it aqueous because it needs to dissolve. Give one, so I'll write aqueous fully, aqueous. Give one expected observation during the 10 minutes that the circuit was switched on. Well, if we look at the diagram, you should be able to see the light bulb, and if electrolysis is happening, then we're going to see the light turn on. Describe how you would wash and dry the key. Well, you wash with distilled water. Distilled water just means pure water, and we dry in an oven. Okay, question 3. Electricity was passed through molten lead iodide, and we also formed a purple gas from the positive electrode. So, what piece of apparatus is missing? Well, it's molten, so that means we need to melt it, and in order to melt it, I need some heat from a Bunsen burner. Clearly label the electrodes on the diagram. Well, the electrodes are here. Give one other expected observation during the electrolysis. Well, like with the previous question, we've got a light bulb, and so that is going to turn on when electrolysis is happening. Light turns on, and when the molten lead iodide cools and solidifies, the ions are not free to move. Now, if the ions are not free to move, then there can't be anything carrying a charge, so you can't get a conduction of electricity. So if there's no electricity, the light turns off. Okay, that's important to remember. If the ions are not dissolved in water or molten, then the ions are not free to move, and you cannot get a conduction of electricity, so electrolysis will not work. Suggest why a stopper is not used. Well, as it says here, a purple gas is given off. So gas produced, stopper. If you use a stopper, then it would cause an explosion because you're trapping that gas. So we don't use a stopper to make sure that there is no explosion. Explain the observation at the positive electrode. Well, a purple gas is given off, and because it's molten, we know that there's only 2 chemicals present. There is either the lead or there is the iodine. Okay, so, and it tells you that a purple gas is given off. Now, the lead isn't going to be the purple gas, so the purple gas is iodine, and this is a 2-mark question, so it's formed from the iodide. Do notice, again, 2 marks. So purple gas is I2 would be mark 1, and therefore try to think of what a second mark would be. Well, it was formed from the iodide. Give one safety precaution, use a fume cupboard. Now you're going to use a fume cupboard because I2 is a halogen gas, and the halogen gas are toxic. So if you form chlorine, bromine, or iodine, so Cl, Br, or I2, they're all diatomic, all of those are toxic gas, and you want to use a fume cupboard. Okay, make sure you review your formative carefully, and you annotate any questions that you got incorrect. If you have any further misunderstandings, review the video, your textbook, and also ask Mr. K. Thank you. Bye.